Hi, I'm James Danckert, a cognitive neuroscientist from the University of Waterloo in Canada, and I'm going to talk to you today about boredom. There are two things that got me into boredom research. The first, that I experience boredom a lot and don't like it. So my research is in the hopes of trying to understand boredom better so that I might be able to deal with it better. And the second reason is that many years ago, my older brother suffered a severe traumatic brain injury as a result of a car crash. And during his recovery, he talked about being bored a lot, which suggested to me that something organic had changed in his brain, and I really wanted to understand that. There are a number of myths about boredom that I think are important to interrogate because they can help us get closer to a good definition of just what boredom is. And I'll start with Jimi Hendrix, perhaps the most famous guitar player of all time. A man who really revolutionized the way that we play the instrument. So when Mike Bloomfield, a rock and roll Hall of Fame guitarist in his own right, first saw Jimi Hendrix play, he was blown away. So he asked Hendrix after the gig, "Man, where have you been hiding?" To which the guitar legend replied, "I've been playing the Chitlin circuit and I was bored shitless." Now, the Chitlin circuit was a series of venues in North America where African-American performers could play safely during the civil rights movement. And clearly, the type of music expected of Hendrix on the Chitlin circuit was not interesting to him, so he tried to play something different. Now, there's no good evidence to suggest that boredom will make you creative. But if, like Hendrix, you've cultivated creative outlets, then when you're bored, you can certainly turn to those. Now, on the complete opposite end of the spectrum to that story is the story of this young man, Christopher Lane. Christopher Lane was an Australian pursuing his dream of playing Major League Baseball in America. While out jogging one morning in 2013, 3 teenagers shot him dead. And when the police asked one of them, "Why did you do it?" he replied, "We were bored, so we decided to kill someone." Now, if you want to believe that boredom could turn you into a creative genius on guitar, then you also have to believe that it could turn you into a killer. And I don't believe that either thing is true. But what do these two stories tell us about boredom? And just what is boredom? I would suggest to you that the in-the-moment feelings of boredom, what psychologists call state boredom, is a signal, a call to action, to do something different. It's telling us that what we're doing right now is not stimulating or engaging enough, and we need to explore the environment for something else. We need to act. And there's an analogy here with pain, an analogy that I get from my friend Andreas Alpadoru, who's a philosopher at the University of Louisville. So in this image that you're looking at here, you would expect that the young cherub would quickly remove his foot from the fire because it's painful. Here's the analogy though. The function of pain is not to cause hurt. It's to galvanize us into action, to get us to do something to deal with whatever caused the pain in the first place. And that's exactly what boredom does too. It's a call to action. To do something different so that we can feel more engaged with the world, do something that can overcome or eliminate or at least reduce our boredom. So I don't believe that boredom will make you a creative genius or that it will turn you into a killer. It doesn't do the hard work of telling you what you ought to do to solve your boredom. That hard work is up to us. So in that sense, the in-the-moment feelings of state boredom are neither good nor bad. It's simply just telling us that what we're doing now is not satisfying and we need to find something else to engage in. And continued failure, though, to adaptively respond to that state signal can have many negative consequences. Boredom proneness is associated with poor mental health outcomes, including increased anxiety and depression, and even something like increased aggression. We know that people who are prone to boredom also tend to have problems with drug and alcohol use. And recently we found that they have a problematic relationship with their smartphones and particularly social media. And that relationship is kind of like an addictive one, where people feel more anxious when they're away from their phones and they need to ramp up how much time they spend on their phones. Behavior that is driven in part by their boredom. And each of these things represents, in some sense, a failure of self-control. So for those who experience boredom more often, more frequently, and more intensely, it poses a particular kind of challenge. It's uncomfortable for the boredom prone to be bored, precisely because they're failing to respond well to the signal, and they know it. They're not engaging in things that are satisfying that desire to be engaged with the world in meaningful pursuits. Now, I don't know whether or not the guy in this GIF is bored while he's waiting for something. But it's entirely possible. He's standing around waiting for something to happen or a friend to come pick him up, and he just tips the bin over. And this represents a pretty big failure of self-control. Most of us wouldn't do that. In several large, typical undergraduate samples that we've tested, we consistently find that there are a strong relationship, a strong negative relationship between self-control and boredom proneness. So we do this kind of work by having people fill out questionnaires that reliably measure trait boredom proneness and trait self-control. And this graph on the left just shows you a scatter plot of the kind of typical correlations that we see in very large sample sizes, anywhere between 1,000 and 2,000 students. And what we find is that people who are high in self-control tend to be low in boredom proneness. And the other way around is true too. People who are low in self-control tend to suffer from boredom more. And age plays an important part here too. So the graph on the right shows you that people who are under the age of 30 tend to have higher levels of boredom proneness than people who are over the age of 30. And in that particular work, even when we restrict our age range to 17 to 22 years of age, we find a similar effect, that the younger people tend to experience boredom more than older people. And that age range, 17 to 22, is important because that is the age at which we're reaching our final stages of neural maturation. The frontal cortex, the front part of your brain, comes fully online in those late teenage, early 20s years. And we see that people get more self-control and probably less boredom proneness. If I was to bring it back now to a call to action, it's worth noting a series of studies recently by Timothy Wilson and his colleagues in 2014. What Wilson and colleagues did is they had people put in a room with nothing but their thoughts. So people had their phones taken away from them, their backpacks. There was nothing in the room to look at, nothing to do in the room for 15 minutes. And in the early studies that they did of this kind, about 1/3 of the people found that experience quite pleasant. About 1/3 were indifferent, and about 1/3 really hated it and said that they were quite bored. But it's the final experiment that I think is most interesting to us. In this instance, they gave people a choice. You can spend 15 minutes in a room with nothing but your thoughts, or you could self-administer an electric shock. Now, everybody in this study had experienced the shock before the 15 minutes began. They'd rated it to be unpleasant, and they'd even said that they would pay money not to experience that shock again. And yet, when they were in the room for 15 minutes, most people chose to administer an electric shock anyway. It seems that we're uncomfortable doing nothing. One guy in this study administered 196 electric shocks. And clearly that goes well beyond curiosity to doing something now just because of sheer boredom. And I also think that this indicates that the human animal is not comfortable doing nothing. So we can dispel some of the myths then of boredom proneness. It's uncomfortable and distressing, so it's not apathy, it's not laziness, and it demands a response. It's a call to action, to find something that's better than what we're doing currently. And in this sense, we can cast boredom in the context of what behavioral economists call opportunity costs. Boredom is sort of telling us that there are more engaging things or more important or more meaningful things that we could be doing other than the things that we have right here in front of us. Even an electric shock seems worth it when there's nothing else that we can do. So think about foraging for berries. Whenever you go to a berry farm to pick your blueberries, you don't stand in front of one berry bush and take all of the berries that are on that bush and then move on. That's not how we do it, and it's not how animals do it. You'll stand in front of a bush, you'll take the biggest, juiciest, ripest looking berries, and perhaps the easiest ones for you to get, and then at some point it'll start to become more difficult to find berries in that bush, and so you'll move on to explore for other options. And this is what behavioral economists call an opportunity cost. Anything that we do comes with an opportunity cost. Whatever you're doing now, you could be doing something else that might be better. And boredom signals those rising opportunity costs. Whatever you're doing now is not engaging, not meaningful, quite boring, and so you could be doing something better. Now, we recently tested this notion without asking people to shock themselves. And this is kind of a replication of Timothy Wilson's work. So what we did is we had two groups of people, sit in a room, and they were instructed to do nothing but spend time with their thoughts. In the first room, there was nothing to do. You can see that indicated by the picture on the left. So this is a replication of Wilson's range of studies. In the second room, we placed a range of things that people could have interacted with had we let them. There was a half-finished Lego puzzle. There was a half-finished jigsaw puzzle. There was a tablet that they could have used to surf the internet. and of various other kinds of objects that they could have interacted with, except we told them, sit in this room with all of these different things in it that you could have interacted with, but look, but don't touch. And then we asked people, how boring were these experiences? And what we found was that people in the room where there were things they could see that they could have done but weren't allowed to do, those people were more bored, suggesting to us that boredom does signal these rises in opportunity cost. It does suggest to you that whatever you're doing now isn't engaging, isn't meaningful, and you really wish you could be doing something else. One of the interesting things about that study is that many of the people broke our rules. We had a spy camera in the room, a little coffee mug that had a camera hidden in the lid. So we were able to see whether or not people did as we asked, sat in the chair and did nothing but spend time with their thoughts. And many people broke the rules. It was as though for them, the boredom was so intense that they really needed to get up and do something despite the instructions of the task. So more recently, we asked people about their experiencing during the pandemic. We asked about their boredom, and we asked about how well they'd been able to adhere to the restrictions of lockdowns and social distancing. This data was collected in late April and early May of 2020. The idea here is that people who are more boredom prone might be more likely to break the rules of social distancing because they really need that, they really feel that urge to act. And that's exactly what we found. We found that people who were low in self-control and high in boredom proneness were more likely to break the rules of social distancing. And perhaps unsurprisingly, those same individuals were more likely to have contracted COVID-19. This is one of the first times in my career that we were scooped. There was a group headed by Vanya Wolf in Germany and Switzerland who did almost exactly the same study and published it about 2 weeks beforehand. The great thing about that in science is that these two studies by two groups who didn't know each other, didn't communicate with each other, found pretty much the same thing. So it seems that for some individuals during those restrictive times of the pandemic, they're high in boredom proneness and they really can't resist that urge to act. And this all highlights for me what I would call the conundrum of boredom proneness and the conundrum of being bored for the highly boredom prone. I love this quote from Leo Tolstoy from Anna Karenina, in which he calls boredom the desire for desires. When we're bored, we want something, we just don't know what we want. Or we want something, but we don't want anything currently available to us. We want something that's not there, but we can't articulate it. And that begs the question of why. And anybody who's been a parent of young children will understand and appreciate this particular anecdote. When your child comes to you and says, I'm bored, what they're actually really saying to their parents is, I'm bored and I want you to fix it for me. So, as the dutiful parent, we trot out options. We tell them, why don't you go play basketball with your friends? Why don't you read a book? Why don't you play with your Legos? And at every turn, the child rejects those options. No, I don't want to do that. No, I don't want to do that. And they're highlighting that conundrum that I talk about, that they want something, but they don't want anything that's currently available to them. So this all suggests that for the highly boredom prone, they're suffering from a self-regulatory problem, what we would refer to as a failure to launch. They know they need to get into action, but they just fail to launch into action. So we've looked at this by employing a notion from social psychology. This comes from Ari Kruglansky and his colleagues, where they look at what they call two different regulatory modes, locomotion and assessment. Locomotors, sometimes referred to as the just do it mode of goal pursuit. These are people that move from one action to the next very quickly. They move from one goal to the next very quickly. And these individuals tend not to feel boredom that much. So people who are high in locomotion and they just get on with things, they just do it, tend not to be bored. Whereas the other regulatory mode, the assessment mode, these people prefer to evaluate all of the options for actions to make sure that they do the right thing. They really don't want to make any mistakes or errors. And these people tend to experience boredom more, as though their fruitless rumination over what might be the best course of action gets them stuck in the moment and experiencing that failure to launch. I've suggested that boredom is functional. It serves a purpose. It's a call to action. But one of the things that account of boredom suggests is that there is an evolutionary history to boredom, that it was selected for at some time in our evolutionary past. And if that's true, then this quote from Erich Fromm, that man is the only animal that can be bored, is wrong. And one of my favourite studies comes from Rebecca Meager and Georgia Mason at the University of Guelph at the time, where they looked at boredom in mink. If you've ever seen mink in the wild, they're quite mischievous little animals. But what Rebecca and Georgia did is they placed two groups of mink in different kinds of cages. In one group, they were in the standard cage that mink are raised in for fur farming, where there's really nothing much for them to do. It's bland. There's not anything really in the cage. The other group had lots of options for things to do, things to interact with. After 2 weeks, they exposed both groups to different kinds of objects, things that the animal would normally avoid, so the silhouette of a predator or the smell of urine of a predator, things that the animal would normally approach. And apparently, according to this study, for mink, toothbrushes are like a laser pointer to a cat. They just love toothbrushes. So they would show them a toothbrush. And then objects that the animal normally wouldn't care about, like a water bottle, that the animal wouldn't be interested in. And the idea was this. If the animals in the bland cage were depressed, they would show less interest in the things that they normally liked, like the toothbrush. If the animals in the bland cages were apathetic, they'd show no interest in any of the objects. They wouldn't care whether it was a positive, negative, or neutral object. If they were bored, then the animals would rapidly approach all kinds of objects. And that's precisely what they found. And they also found that the animals housed in the bland cages overate treats at the end of the experiment. And this is something we see in humans too. Humans often overeat out of boredom. And what this study suggests is that there is indeed an evolutionary history to boredom, and that we see boredom in some species other than humans. And that brings me back to the notion of foraging. So the boredom signals rising opportunity costs, pushing us to explore the world for something more satisfying to do. So what we thought we would do is we'd create our own foraging task and see whether or not people who are high and low in boredom proneness might approach this foraging task in distinct ways. And we started this work with a colleague of mine, Marla Sokolovsky, who is an evolutionary biologist at the University of Toronto. Marla works with the fruit fly, Drosophila melanogaster. And what you're looking at here are heat maps of exploratory behaviours of the larva of the fruit fly. So the fruit flies are put into these dishes that have different food sources, and then you can measure where they walk around those dishes, if you like, how they explore the space of those dishes to find the food. And Marla finds two phenotypes along a foraging gene in the fruit fly, phenotypes that she calls the rover and the sitter. And the rover explores their environment quite widely. And that actually comes at a risk or a cost to the animal, because any time the animal explores an environment wildly, they put themselves at the risk of predation. The sitter, on the other hand, prefers to hug the environment, the boundary of their environment. And you can think about these things in terms of risk tolerance. The rover has a high level of risk tolerance, and so they explore quite widely. The sitter has a low level of risk tolerance, and so they tend to stay to the safety of the boundary. And one of the motivating factors for us to do this research then comes back to these regulatory modes that I talked to you about of locomotion and assessment, because to us, there seemed to be a parallel between the locomotors and the rovers. These are people and flies that get on with things and just explore their environments widely. And the assessors and the sitters, these are people and flies that tend to have a low risk tolerance and adopt safe behaviours that minimise risk and minimise error. So we wanted to see whether or not those two things would be conserved in humans. So to test this, we created our own foraging task. We had people swipe their way through a touchscreen environment and then tap on these red berries that they saw to try and collect or catch these berries. And they could explore the environment in any way that they liked to. We could look at simple metrics like path length and the number of berries they picked. But when we did that, those metrics were not quite sensitive to individual differences in either trait boredom proneness or regulatory mode. So instead, we turned to path classification. And you can see here we had three different groups when we did this path classification. A boundary biased group, and you can see this is already starting to look suspiciously like a sitter in the fruit fly. This is a group that started in the middle, found the boundary, and hugged the boundary. Then we had what we called a systematic group. These were people who explored the environment systematically back and forth, either left to right or up and down. And the third group we couldn't classify in either of those two ways, so we called them mixed. But you can see, as I've already mentioned, that the boundary biased guys look a lot like fruit fly sitters. And here you're looking at heat maps of the exploration of that foraging task in the humans compared to the fruit fly rovers. And this is now based on the human ortholog of the foraging gene, a gene known as PRKG1. And we're looking at a particular single nucleotide polymorphism on that gene. And the homozygous A allele carriers of this gene, shown on the bottom right, tended to hug the boundary of our environment, very much like the sitters. The homozygous C allele carriers tended to explore the environment more broadly, much like the fruit fly rovers. So more specifically, we found that the presence of the A allele on this particular single nucleotide polymorphism predicted a preference for assessment regulatory mode. So the A allele carriers, the homozygous A allele carriers, tended to adopt an assessment mode. The homozygous C carriers tended to adopt a locomotion mode. And those same individuals that preferred assessment also tended to hug the boundary of our task. And the same individuals that preferred locomotion didn't show that same bias to hugging the boundary. So it was as though our assessors were behaving like fruit fly sitters. Next, of course, then we look at boredom proneness and self-control. So those same individuals that preferred an assessment regulatory mode, hugged the boundary of our foraging environment, also tended to be high in boredom proneness and low in self-control. Now, we've replicated this in another sample, and we're interested in looking at a range of other genes that might be important for things like transport of the neurotransmitter dopamine, as that might be important for sort of reward processing. So you'll have to stay tuned for that work. So I'll finish now by talking about brain states and boredom. We've been interested in looking at what is the brain state, the neurological signature, if you like, of boredom. And we look at this in state boredom because we would need much larger numbers in our scanner to look at trait boredom proneness, and that starts to become expensive. So people have used lots and lots of different ways to make people bored, like writing out phone numbers from the telephone book or copying down scientific references of concrete, studies of concrete. We even had people read a passage from a book about the joys of soil, which really effectively made them bored, especially when we compared it to them reading passages from Harry Potter. But to look at what was happening in the brain, we needed a video. We needed something that people could look at that might help make them bored. So one of my students, Colleen Merrifield, created this video of her father and her brother-in-law folding laundry. Two guys for 8 minutes, occasionally asking each other for a clothes peg, is really boring. Trust me, it's not something you want to sit through for 8 minutes. So we had people watch that, and while they did, we looked at what was going on in their brain in an fMRI scanner. And we started with what is known as the resting state scan. Here you look at what is going on in people's brains when they're doing nothing. They have maybe a cross in the screen that they can look at for 8 minutes. It's a little bit like that Wilson study where they're in a room with nothing but their thoughts. And when you do this, you find a range of brain areas that are activated known as the default mode network. And that's what you're looking at here, particularly parts of the brain in the back of the brain, the posterior cingulate, the precuneus, and we've got bilateral activation of the temporoparietal junction. So we see these areas when people have no external task to do. There's nothing out there in the world for them to engage with, so they only can engage with their own thoughts. And they typically engage in self-referential thoughts, things about planning for the future or thinking about nostalgic memories from the past. This is the kind of thing that activates the default mode network. And then when we show them the boredom scan, we see the boredom video, we can see in that scan that much the same areas of the brain are activated, that default mode network. The interesting difference here is that there is something external for them to do. There's a movie to watch, and we told them to pay attention to that movie. It just turns out that the movie is so boring that you just switch off and go back to your own internal thoughts. Now, we had to compare that to something different, so we looked at an interesting movie, 8 minutes of a BBC Blue Planet documentary, and you see the areas of the brain that were activated, the default mode network were activated during that resting state and boring scan, were deactivated when people watched something interesting. If that was all we found, it might have been a little bit disappointing, but we looked a little more closely, and the arrow that you see in this image here is pointing to a part of the brain known as the anterior insular cortex. And this part of the brain is really important for representing things in the world that are relevant to you, that are salient to you right now. And in the resting state, there's no activity, no upregulation, no downregulation of the insular cortex, because there's nothing out there in the world of any relevance. What we find in the boredom scan is that there's downregulation of this part of the brain. It's as though you really are shutting off, saying even though there's a video to watch, even though there's a movie for me to pay attention to, it's so boring, it's irrelevant, let's just switch off the insular cortex. And again, when we compare that to the interesting scan, we find that that area of the brain is actually upregulated. There's a lot more work to be done to try and understand the brain states that are associated with being bored, but it seems that this part of the brain in particular might be really key to how we engage with things that are in our environment. So this is perhaps one of my favorite quotes, although I think it's kind of dangerous to read Nietzsche. This is not just because I'm an atheist and I find the quote funny, but this quote, "The boredom of God on the seventh day of creation would be a subject for a great poet." And I like this because you might imagine that God on that seventh day could sit back in her lazy chair and say, "Wow, look at everything that I've created. Isn't it fantastic?" But even God needs to say, "What next?" And that essentially is this idea of what boredom is telling us to do, not necessarily what next, but what can I do that's engaging? What can I do now? What I'm doing right now isn't engaging, and I need to find something else. And it really casts boredom in the context of goal pursuit. And as humans, we're always pursuing goals for ourselves, big and small. And what boredom really signals is that we're not effectively pursuing goals right now. And in that sense, as I've suggested already, that boredom is this call to action to launch into something that is satisfying or meaningful to us. And as I suggested early on in the talk too, that being prone to boredom is associated with all kinds of ill effects, higher rates of depression and anxiety, problems with drug and alcohol abuse, and so on. So boredom is telling us to act, but we need to find adaptive actions. We need to find good, positive ways to respond to the boredom signal. And we need to find ways to respond to boredom that help demonstrate what psychologists call our agency, help demonstrate to ourselves that we are in control of what we pursue. We are in control of our lives. We're the author of our lives, if you like. Now, this image is intentional, the image of an elevator door from the inside. The closed door buttons on most elevators, and many of the crosswalk buttons in big cities like New York City and London, are useless. They actually do nothing. And even though I've told you that now, I bet that the next time you're in an elevator, you still push the closed door button because it feels good to push that button and believe that you've had an effect, even if you know that the button itself is useless. We like to feel like we are in control, that we are having an action and having an effect on the world. And boredom is telling us that right now we are not having a positive effect on the world. We are not exercising our agency. We are failing to demonstrate our own efficacy as agents. So the $64,000 question really is, what should we do when we're bored? And I think that there's a lot of work to be done yet on that. There's not a lot of data out there to try and tell us what the most optimal ways are to respond to boredom. So what I'm about to tell you is really just my opinion. But I think one of the first things that we need to do when we're bored is to take a breath and stay calm. Boredom can feel agitating. It can feel aggressively dissatisfying. But if we succumb to that agitation, that's the kind of thing that might push us to the maladaptive responses, to staying on our phones playing Candy Crush, or to having another drink of beer, or to staying on our gambling machines. We take those short-term solutions to boredom when we don't first try to calm down and relax a little bit and not succumb to that agitated feeling of boredom. The next thing to do is to think about, well, why is it that I'm bored right now? Perhaps I could change the story. And there's a lot of stories from people who work on assembly lines showing exactly that. We might all imagine that assembly line work is quite boring. But some workers will say they challenged themselves to beat their personal best from the previous hour. So now a boring job has become a personal challenge, and it's no longer boring. So if you think about why the current circumstance is boring, you might be able to change the narrative in that way. And the third thing I think we should do when we're bored is to think about, well, what is meaningful in my life? Boredom is telling us that what we're doing right now is not satisfying our desire to be an effective agent and our desire for meaning. So perhaps we could use the signal of boredom, use the experience of boredom to try and understand what matters most in our lives. It doesn't have to be on a grand scale, but it's worth pausing and thinking about, what do I think I want to pursue? What are my goals? Now, I've used this picture of a young boy sitting in school, clearly bored out of his skull, a lot over the years. And there's something about it that I love. And it's not just that he's clearly bored, but I think it's that he's hostile about it. If you look in his eyes, he's clearly not happy that he's bored. He's very unhappy and dissatisfied. And I think I like that because that is what boredom feels like to me. It's this call to action because it's really unsatisfying to be in a moment where you feel like you're not being effective or you're not engaged in something that matters to you. So I think if we can avoid succumbing to that restlessness and agitation that commonly comes with being bored, we can give ourselves a chance to recognize boredom's upside, that it's telling us that we are in fact the author of our own lives and we can take positive control of that and choose things to engage in that matter to us. Thank you.